is Formative D, Semester 2 for Pre-Calculus. So we are given a triangle ABC with the measure of angle A is 42, side A is 8, side C is 10 units, and that's us to solve the triangles. So we're going to start by drawing a triangle, but we want to notice since angle A, side A, and side C, the angle is not in between our two sides, so we actually have a side-side angle case, and with that there's a possibility of an ambiguous case. So we're going to start by drawing our triangle. I always draw it so that my angle is in the bottom left corner. This is 42 degrees. Okay. Now the side opposite of our angle A is going to be side A, and there's 8 units. The side opposite of our C is, our angle C is C, and that is 10 units. So since our A is less than our C, so since our opposite side is less than our adjacent side, there's a chance for multiple triangles. We could either have 0, 1, or 2 triangles. So first, to see how many triangles we have, we need to see what this height is. Because if A is really small, there's a chance that it does not even make a triangle. Or there's a chance if it equals a height, then we just have one right triangle. Or if it's bigger than that, we could have 2 triangles. So we draw in our altitude, we're drawing our height, and that makes a right angle. So I'm going to call this side length, this dashed line, my h, my height. So now since I have this triangle, A, B, down to this point, it's a right triangle, I can use SOHCAHTOA. So I'm going to say sine of 42 degrees equals opposite over hypotenuse, so h over 10. I'm going to multiply by 10 on both sides. Get 10 times sine of 42 equals h. I'm going to type that directly into my calculator, and I get that my h equals 6.69 units. So I know this height is 6.69 units. My A is bigger than my height. So I'm now going to say my A is bigger than my height. So since my A is bigger than my height, it can't be the height. So I'm not going to have one triangle. And I certainly won't have 0 triangles because that would mean that my A has to be less than my height. My A is bigger than it. So I'm going to actually have 2 triangles. So with that, I'm now going to have 2 triangles. I'm now just going to go ahead and solve for those 2 triangles now that I know my cases. So the C is now going to turn to C1, and we're going to try and find that angle. I already have an angle on a side and another side, so I'm going to use law of sines for my first triangle, and I'm going to solve it all in blue. So my first triangle is what we see here exactly. So I'm going to have sine I'm going to take sine of 42 degrees over its opposite side, which is 8, equals sine of C1 over 10. This is my law of sines. To find my angle C, I'm going to multiply both sides by 10. I get 10 times sine of 42 over 8 equals C1. Sine of C1. Now, to measure C1 by itself, I need to take the inverse sine of both sides. I'll take the sine inverse sine of here. I'm going to take the sine inverse here. And I'm going to type this directly into my calculator. Sine inverse of 10 times sine of 42 divided by 8, and I get 56.76 degrees. And that equals my angle C1. So I now have this angle, and now I have to try and find my angle B and my side B. So to find angle B2 or B1 is just, I have a triangle, so I know the angles of triangles is 180. So I can take 180 minus 42 minus 56.76, and that equals the measure of B1. When I do that, type that into my calculator, I get that angle B1 equals 81.24 degrees. the only thing I am missing in this triangle is this length of B1. So to do that, I need to set up another law of sines ratio. And now, you could use C1, but I've already rounded that answer to 56.76 to be, so instead of calculating a rounded answer from a rounded answer, I'm going to be more precise by using the given information. So I'm going to take 8 over sine of 42 equals B1, what I'm looking for, over sine of 81.24. Then I'm going to multiply both sides by sine of 81 over 81.24 to get sine of 81.24 times 8, all divided by sine of 42 for B1. And I get that side length B1 equals 11.82 units. So I have just solved this big blue triangle, A, B1, and B1, and C. But, like I said, there's a possibility of a second triangle, and that second triangle occurs if this side AC is actually swept inward and connects here, and that's where C could be. So C could be either one of these 2 points, and if we notice, if C here, that's my side A equals 8, that means that this side, this leg got swept inside the triangle to be also A could be 8. So if that's the case, I have 2 sides that are equal in a triangle, and that means that this is my isosceles triangle, and their corresponding angles are also congruent, which would mean that C2 is congruent to C1. And I know that C1 was 56.76. So to find my C2, what would be my new triangle? My new triangle is this one, this green triangle. I need to find this angle is C2. So I'm going to do this. To find that angle of C2, I know that these 2 angles make up that equals 180, or a straight angle. So I can take 180 minus that 56.76 equals C2. When I type that into my calculator, I get that the measure of C2 equals 123.22 degrees. So that's this angle. Now, if before my blue angle is B this whole side, but if I shoot that A in, my angle of B changes as well. So I'm going to have a separate B2 angle. And the way I calculate that, same thing with my law of sines, I'm going to take my sine of 42 over 8. To find B2 actually, I have 2 angles in my triangle. So I have A and C2. To find my third side, I know that the sum of all angles in a triangle are 180. So I can take 180 minus 42 minus that new C2, 132.22, to get angle B2. And that comes out to be 14.78 degrees. So angle B2 equals 14.78. And then finally, my last thing would be to find B2, this short side of my triangle. So to do that, I'm going to set my law of sines now, and I'm going to take 8 over sine of 42 equals B2 over sine of that new, what was B2, which is 14.78. Multiply both sides by sine of 14.78. Divide sine of 42 times B2. I'm going to plug that directly into my calculator. Sine of 14.78 times 8 divided by sine of 42 to get B2 equals 3.05 units. So, as a recap, if you are given a triangle with the angle not in between the 2 sides, I have C and A there, angle not in between, there is an ambiguous case possibly, so I might have 0, 1, or 2 triangles. I need to first create my height to determine how many triangles I may have. Since my A is bigger than the height, but smaller than the opposite side, I will actually have 2 possible triangles.